Hi guys, so in this video we'll be discussing about two more problems which is very much important for interview perspective as well as for knowledge perspective. Like we have to calculate number of iterations in a time complexity, and do you know that they can be infinite as well? Time complexity can be infinite as well. How can the time complexity be infinite? Let's understand through these two codes. So first code, I will this is not an infinite time complexity code, it's having some time complexity. So we will explain you like how these two are working with what is the number of iterations so that you can guess the time complexity. Okay, so here I've initialized with the value of n. N can be any value you can consider, like 5, 6, 7, 8, 10, 12, 15, anything. And here I have written one condition in a while loop. While I is greater than equal to 1, I will be equal to I by 2. Means in every iteration I will be dividing by 2. So if I am writing first, when I was equal to n, the value was n initially. Okay, then I got divided by 2. Then again when I got divided by 2, the value became what? It became n by 2. Okay, then I divided by 4. Okay, then again divided by 2, the value will be again n by 2 divided by 2, which is equal to n by 4. Okay, then I by 8. Then what will be the next value? It will be like n by 8. Okay, n by 4 divided by 2. So if it keeps on going, then where it will lead to? What will be my end value here? It will be like n upon 2 to the power k. It will converge at this particular position, n divided by 2 to the power k. Till this point it will go. So if I just try to minimize it, like if we want to find a time complexity for that, now we'll get some idea, right? What will be the time complexity for this? It will be like I is equal to n upon 2 to the power k. Okay, so let's suppose this value is converging at 1. So this condition will get satisfied, right? I is greater than equal to 1. So this value is greater than equal to 1. Understanding? So if I am removing this greater than as of now, so n upon 2 to the power k, let's remove that. So if I do n upon 2 to the power k is equal to 1, then what will be the value of k here? The value of k will give you the number of iterations, which will in turn give you the time complexity of this iteration. Okay, so 2 to the power k is equal to n. Okay, so if I take log both sides, it will be like k log 2 to the base 2 is always 1. I have told you in the previous video. So k will be equal to log n to the base 2. That is very important because I have taken log both sides, taking into consideration that the base is 2. Okay, so here we have got the time complexity as log n to the base 2. So this loop is having a time complexity of log n to the base 2. Okay, so if we are not dividing by 2, the same I value, if it is not dividing by 2, if we are doing some other operations like s equal to s plus 1, like that if we are doing, then time complexity will be what? Time complexity will be, it will go till I value is n. So n greater than equal to 1, condition satisfied. If it is I minus, so it will be decrementing by 1, like 8, 7, 6, 5, like it depends upon this I value. So time complexity will be O of n. It's a worst case time complexity is O of n. Okay, so this we have to consider. Time complexity is n. So the value of n will determine till what time this iterations will go. So this is, it can be taken care of by the value of I. So this was one problem. Now I will jump onto the second problem. So here I will understand what will be the time complexity for this code. Okay. Now let's understand what's the time complexity for this code. What I have written over here, if you can see, I have initialized I as n. While I is greater than equal to 1, I is equal to I into I. Okay, so now what will be my time complexity? So if you can understand, first I value is n. So n is greater than equal to 1. Greater than 1 means condition gets satisfied. I will be what? I will become I into I. So it will become n into n. Understanding? Now in second iteration, n square, I will be n square, right? So n square is greater than equal to 1, condition will be satisfied again. So it will be like n square, it will be like n into n, which is n square. Then again it will be multiplied with n. Okay, so now in the next iteration, the same thing will happen. It will keep on getting multiplied infinite amount of time, because it's a diverging loop, it's not converging loop. So converging loop means it will converge at one particular point and the iteration will break at certain position. So there will be certain value at that point, the loop will break out and it will terminate the code. But here the code is not getting terminated, it's running infinite time, because this condition will always be true. So if you know the while loop, so within while there will be like, if I'm writing true, so it will execute till the while loop is true. So here I greater than equal to 1 will always be true, because here is what it is written over here is I into I. It's a diverging condition, it's not a converging condition. So diverging condition will return me infinite loop. So this will run infinite times, so the number of iterations will be infinite, so time complexity will be infinite. So I've learned a lot here, right? It's a very important concept to understand. So interviewer can ask you, can you give me an example of infinite time complexity or infinite number of iterations? So this you can tell as an example. So I hope you got the concept, you got the clarity. So in the next lecture we'll be coming with some for within for. Okay, so that will be understanding. So just practice this type of codes, try to do some trial and error here, and you will see the changes coming, and you will just keep on experimenting, you will learn a lot of things. So see you in the next lecture. Till then, bye bye.